If you look at the planet Earth from space, it looks like a blue marble. There are white and gray streaks, as well as green and brown splotches. All in all, the result is a rather well composed whole. However, if you were to arrive from space and land on our planet, you would find that there are four very distinct spheres that make up the planet. Earth's four spheres are the atmosphere, biosphere, geosphere, and hydrosphere. However, while these each are very distinct, they're all interconnected. But before we get to all that, we have to land your spacecraft. Assuming that you have reached orbit around the Earth, the next step to exploring the planet Earth is entering the atmosphere. Extending more than 300 miles from the surface of the Earth, the atmosphere does a great deal for the other spheres. It blocks UV rays, provides an avenue for rain and snow to fall, and provides the oxygen and carbon dioxide essential for life on Earth. The atmosphere is broken into different layers depending on their distance from the surface of the planet. All of the life found on Earth makes up the biosphere. As humans, we very rarely leave the biosphere. In fact, even when we fly above 1,000 feet, we take enough of the biosphere with us to make sure that we survive. There's a great deal of diversity in the biosphere. As a result, just as we have different layers of the atmosphere, there are also different zones of the biosphere. These are known as biomes, and chances are you're familiar with the concept, if not the name. Rainforests, grasslands, tundra, and deserts are all examples of biomes. If your spaceship made its way through the atmosphere without being noticed by anyone living in the biosphere, chances are that it would land in the hydrosphere. The hydrosphere is the name given to all the water around the world. More than 75% of the world's surface is covered by water, so chances are you would land there. It includes the vast majority that is in the world's oceans, as well as glaciers, lakes, rivers, and groundwater. Beneath the atmosphere, biosphere, and hydrosphere is the fourth sphere of the planet, the geosphere. The geosphere is made up of all the rocks, dirt, lava, and other minerals below. It is by far the heaviest of the spheres. It is also the least explored. While we live in the biosphere, routinely fly through the atmosphere, and can send submarines throughout the hydrosphere, we have only gone a few miles into the geosphere. Chances are you're starting to wonder if some of these spheres can blend together. If you're in a tunnel in a mountain, are you in the geosphere, biosphere, or atmosphere? A case could be made for each. The answer is actually quite frustrating. You are in all three. In fact, the boundaries between Earth's spheres are less concrete and really more theoretical. Identifying the different spheres can be more useful when following something through a cycle. For example, we can follow water through its precipitation cycle to see how it moves through each sphere. It is evaporated from the hydrosphere, falls from the atmosphere, consumed by the biosphere, and absorbed by the geosphere. Similar examples can be found throughout other spheres. Materials like coal are mined from the geosphere and burned by humans in the biosphere, with the waste products going into the atmosphere and the hydrosphere. In any event, the effects of each cycle are felt in other cycles in other spheres. Coal waste introduced into the hydrosphere can cause rain dropped onto the geosphere to become increasingly acidic. In this lesson, we look at the four spheres that make up the planet and how they interact. The atmosphere goes from Earth's surface to up around 300 miles, and the biosphere makes up everything living in the world. The geosphere makes up all the rocks, soil, and other minerals from the highest mountains all the way to the center of the Earth. Finally, the hydrosphere is made up of all the world's water in the oceans, lakes, rivers, glaciers, ice caps, and groundwater. These four spheres all interact with one another, as evidenced by the precipitation cycle and the effects of pollution on the world.